Hello and welcome to Chemistry Chats with Cochrane Year 11 edition. This is our final little batch of chemistry chats. This is the first of a few episodes, I'm not sure how many it will be yet, all about gas calcs. Now, essentially with this gas calcs little section, we're going to look at some basics calcs, some complex calcs, some basic calcs with stoic, some complex calcs with stoic, some complex calcs with mixed stoic, and some complex calcs with mixed stoic, and a few extra bits. So we're going to start at the very beginning here with some basic calcs, and these calcs are going to be super simple. First of all, what is the number of moles of 21.54 litres of CO2 at STP? A reminder that STP is at 0.0 degrees Celsius and 101.3 kPa. Now, if I open up my data sheet, I can see there that my formula is N is equal to V on 22.71, and that is that at standard temperature and pressure, 1 mole of any ideal gas occupies a volume of 22.71 litres. So that is my formula. I know from my question that my number of moles is unknown and my volume is equal to 21.54 litres. I can then substitute these values in by saying N is equal to 21.54 divided by 22.71. And when I do this, I get the number 0.94855 moles. Super simple. Okay, second question. What is the volume of 0.785 moles of neon gas at STP? A reminder, at STP, what's my formula? N equals V on 22.71. Now I hear some of you say, but Mr. Cochrane, we normally write out everything we know and what we don't know before we select a formula. The reason we select the formula first is because this bad boy is at STP and we don't want to get our formulas mixed up. So there's our formula. What do we know about? Well, we know that our number of moles, our lowercase n, is equal to 0.785 moles. And we know that volume is equal to unknown. I can now rearrange my equation and say that V is equal to N times 22.71, which I can then say 0.785 times 22.71, and that gives me 17.83 litres. Happy days. Okay, so that is some basic calcs. Now let's look at a few more complex calcs, a couple more examples here. What volume of 2 moles of gas would exist at a pressure of 125 kPa and 54.3 degrees Celsius? So before we get started here, I'm just going to switch my pen color so we can gain some information. First of all, the question is saying what volume? So we're saying V is equal to unknown. The second thing that our question tells us is that we have 2 moles of gas. So we have N is equal to 2. A pressure of 125 kPa. So we have P equals 125 kPa. And this guy here, we have a temperature of 54.3 degrees Celsius. So this is everything our question tells us about this specific problem. We have an issue, however, because temperature in Celsius is no bueno. We need to change this temperature to Kelvin. And so how do I do that? Well, I look at my data sheet and I see that at 0 degrees, temperature is 273.15 Kelvin. And so I've just got to remember that I either need to change this number at the beginning to 54.3 plus 273.15, which will give me 327.45 Kelvin. So I can do it here right now in the thing, or I can chuck it in my formula itself. So that's just something I've always got to remember. I have to take this temperature to Kelvin. So my question is, what volume of 2 moles of gas would exist at a pressure of 125 kPa and 54.3 degrees Celsius? The only formula that relates all of these things, V, N, P, and T, is PV equals nRT. So this is all my pre-work. I haven't answered the question yet, but I have got some work done. It is worth noting that bad boy there, the temperature conversion, is worth usually a mark. So that's worth noting. Okay. So I now need to rearrange my equation to isolate volume. So I can say that V is equal to nRT divided by P. I can now substitute some values in. My number of moles is equal to 2. R is the universal gas constant from my data sheet, which is 8.314. My temperature, I've already calculated. I can actually put it in here like this though also. 54.3 plus 273.15. And then I'm going to divide that all by my pressure, which is 125 kPa. Now, if I was to chuck that in a calculator, I would get the answer 43.56 litres of gas. So there's my final answer. So as we can see, complex calcs, not that much more to it, just a few more steps. 1 mark for temperature conversion, and then 1 mark for the working and the answer. Very good. Okay, let's look at another example together. This time, we're asking the question, what pressure is 0.547 moles of gas with a volume of 45.3 litres and a temperature of 108.9 degrees Celsius? So, first thing here we're going to note is that the question is asking us what pressure, so we know straight away that pressure is equal to unknown. We know here that N is equal to 0.547 moles. We know that we have a volume here. I haven't put a comma in there. V is equal to 45.3 litres. And we have a temperature of 108.9 degrees Celsius. Now, of course, we know that 108.9 degrees Celsius is no bueno. That needs to be in Kelvin. So temperature is actually equal to 108.9 plus 273.15. And when I do that calculation, I get 382.05 Kelvin. Now, I need to select a formula. What formula? In this circumstance, it's PV equals nRT. Total side note, and not related necessarily to this question, but you can actually do STP calcs with this formula as well if you only want to use one formula. It's just extra steps. Okay, now I need to rearrange this equation to say that P is equal to nRT divided by V. And now I can just substitute in some values. Oh, that was a little bit damning. That was my year 12 assessment. And Barney's telling me I've stuffed up some multiple choice things. Whoops. 0.547 times by 8.314. Multiplied by temperature, which is 382.05, and divide all those by my volume, which is 45.3. That leaves me with a very, very low pressure of 38.35 kPa. Very, 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 very low pressure. So as we can see there, that's happy days. That's beautiful. Again, what do we get? We get 1 mark for the temperature and 1 mark for the final answer. Beautiful. So a little bit more complex than STP, but still not really that complex. Okay, question 3 then. What temperature would 6.54 moles of a gas be if it has a volume of 31.3 litres and a pressure of 456 kPa? Well, first of all, it tells us here what temperature. So what are we looking for? We're looking for temperature. It tells us our number of moles, N equals 6.54 moles. It tells us volume, V equals 31.3 litres, and we have a pressure, very high pressure in this circumstance, of 456 kPa. So we have there our things. What's the one formula that unites all of these things? Well, it must be PV equals nRT. And so now we've got to substitute in some values. So again, let's rearrange this equation to say that T is equal to what? PV divided by nR, I think. Does that sound right? I don't know. We'll see. Hopefully it's right. Let's substitute in some values. 456 of pressure times by a volume of 31.3. Divide all that by 6.54, because that's my number of moles, and multiply that by 8.314, because that is my universal gas constant. Chuck those all together, I get a value of 262.5 Kelvin. Now, this doesn't actually tell us in degrees Celsius or in Kelvin. I'm going to go ahead and move it to degrees Celsius because I think that is a better unit. But it doesn't actually matter. And if the question doesn't ask you, it actually doesn't matter. But we're just going to do it here just to make sure we're on the same page. 262.5 minus 273.15 will give me my value in degrees Celsius, which is negative 10.65 degrees Celsius. So even though this is probably actually a better answer as Kelvin, that is how we would work it out in degrees Celsius. Now, how would you decide which answer to give, whether it's Kelvin or Celsius? Here's the big idea. It really does not matter. You can choose either one every time. I would usually go with Kelvin because it's less work, but there might be a time where a question specifically asks you for degrees Celsius, in which case there's an extra mark allocated. In this circumstance, it would be better to go with this because it's a nice whole number. It's not negative, but either way, it doesn't matter. Okay, so there's 3 different calcs using PV equals nRT. I don't know how long we've been going, 10 minutes. I think it's probably enough for now. In the next video, we'll do calcs with Stoic.